Thank you guys for joining me. My name is John Gravois. This talk is called Building Apps with Esri Leaflet. How many of you guys haven't done any development with Leaflet yet? You want to get started? Oh, we got a split. We probably got a little more than half. Okay. Basically, I did a couple talks in DC a couple weeks ago. I did an intro talk and an advanced talk, and just smashed 90 minutes worth of slides to do this. So we'll see how that goes. You could say described every great success story. It could be a disaster. We'll see. I think we'll be all right. All the demos, all the code, the links, there's a ton of links in the slides. So I'll put up another one at the end, but if you want to take a picture or follow along, all the resources, all the reference materials accessible from the slides, it'll go up on the proceedings page too. Basically, we want to talk about some fundamentals, get started, talk about what Leaflet is, the patterns and the mentality and the differentiators from Leaflet and some of the other libraries that are out there. Talk about what's new, some of the stuff that's gone on in Leaflet and the greater ecosystem, and then some of the stuff that we've been working on. And then take a little bit of a Jungle Book cruise. I wrote some demos here in the last month or so leading up to just show off some new wacky stuff. Maybe it'll be useful for you, or maybe it'll just serve as a proof of concept or something to get your own mind going. And we start every Esri Leaflet talk with a disclaimer. If we're not already aware of this, Esri Leaflet's an open source project. It's Esri's most popular open source project, but this is not a bona fide product that we're selling and sort of treating. It doesn't have a product life cycle and what do they call that? The roadmap for the future. It's a real open source project. We've got contributors coming from all over Esri, and we've got lots and lots of contributors from the community as well. So we're trying to steward an open source community around it, which makes it a little bit of a free-for-all. So that's the disclaimer. I did a quick count a week or two ago, and we've surpassed 50 contributors on our main project page, and I was surprised to see there's only about a dozen that come from Esri. So we have more non-Esri contributor count than we have core Esri staff, which I'm pretty proud of. We've got people logging issues, submitting pull requests, finding issues, and talking with each other on Stack Overflow, some of the other forums. So that's something that's important to us as well. So starting from the very beginning, what is Leaflet? Leaflet, this is their own catchphrase. They call themselves the leading open source JavaScript library for mobile-friendly and interactive maps. So Leaflet's been around for a while, but it's become prominent. You see it in a lot of journalists and online newspapers, end up using Leaflet for their data science stuff. You see it on Craigslist. GitHub itself uses Leaflet. It's just this sort of pervasive thing that's caught wind, and a lot of web developers really like it. They like it because it's small. The footprint of the API itself is tiny. It's stable, and a lot of other people use it. So once you've got some traction and people are talking about it, it's easier to find resources. So the thing that I think is the most important to sort of remember when we talk about Leaflet is Leaflet was written for and designed for putting maps on the web for non-GIS folks. So this is a API that's oriented towards or designed with the user in mind of a web developer who doesn't know about map projections or schemas and geodatabases. It's meant to make it as easy as possible. So in the code here, you can see this is a contentious issue. We pass y-x coordinates, the lat long. So everybody knows lat long, but in actual coordinate positioning, to pass y-x coordinates is counterintuitive to the geographers, but that's how Leaflet does it because it's not designed for geographers. You could have an argument about it, that's just what it is. The other thing is the code samples for Leaflet that you'll see, because it's sort of designed for developers, there's a lot of terse examples. So this idea that we would instantiate an object, have some function factory so we don't even need to new up that object, and then immediately start chaining methods together. This is something that web developers like to write terse code, but when you're just getting started writing JavaScript, it can be a little bit intimidating or I think unnecessarily obfuscating to not call methods one at a time and step through your code and see what methods are succeeding and what are failing. So it's just something to keep in mind. The samples you're going to see are very likely going to use method chaining. You don't have to unless it's what you want to do. So how small is Leaflet? 36 kilobytes, that's, by all intents and standards, not that many ones and zeros. Leaflet stays small by not sort of capturing every edge case and doing everything possible. It sticks with the basics. 36 KB, to give you a little frame of reference, is only a tiny bit bigger than that individual map tile. So as soon as you load your map and start loading your tiled base map layer, you're already loading a lot more KBs than just Leaflet. But to put it in context a different way, hopefully that's clearer over there than it is from here. Leaflet is also so small that it leaves you out to pasture, or leaves it up to you to do things that you might think that the API was going to handle for you. If you have a GeoJSON file, which is Leaflet's lingua franca, you have to make your own AJAX request. So you're either using raw XML HTTP requests and writing a while loop, or you're using another plugin to help you just go fetch that GeoJSON file. And this is something that is surprising to folks that have used some other mapping APIs that are a little bit more robust and complete and attempt to be a total solution. But it's not a mistake on Leaflet's part. So here you can see you load Leaflet, the CSS and the JavaScript, you load another plugin. You can still, lots of developers are writing plugins. You kind of mix and match plugins as you like. I think part of the popularity is that it fits the mind frame of whatever you call the stereotypical web developer to say, don't give me any more than I want. This idea of having an ecosystem of plugins and having developers who are willing to write additional plugins and share them with the community and let everybody go and pick and choose the stuff that they're interested in is something that comes more natively. So that's just the way Leaflet's ecosystem works. And it's a big plugin community. If you look here at leafletjs.com plugins, you can see here on this page, there are dozens of even categories of plugins, and these are even some of the vetted ones. You can see Esri Leaflet here. There's plugins just for base maps, for other kinds of layers, for tiled images, for loading stuff, for vector tiles, for overlaying data. There's plugins all over the place. And this isn't an exhaustive list. These are some of the ones that have been promoted and verified as being really dependable. There's a lot of plugins out there. And at Esri, we thought, that Leaflet's really cool. Wouldn't it be cool if we wrote some plugins for Leaflet that made it really, really pleasurable and easy to work with ArcGIS services? And we followed the same model. So this is a bit of a mouthful, but Esri Leaflet is a plugin, but it's also a tiny little ecosystem of extra plugins so that you can pick and choose the Esri stuff that you're interested in and not really ever get a hold of more than you're interested in at a time. And the mantras or the operating principles of Esri Leaflet is provide sensible defaults. If the most common thing that's done that should be very simple to do and shouldn't require a lot of input parameters. We should just assume you want to do the normal thing and allow some customization opportunity and keep it simple. So we made an intentional decision with Esri Leaflet to not try to expose every ArcGIS service that you'd ever heard of or ever will hear of. It's just the most popular stuff. Because a lot of folks are writing apps, they want to write something fast and ship it. They have a common workflow and it makes it a nice choice. So that idea of the API design, it's incomplete on purpose because it's just the most popular stuff. So taking a tour, the way I'm going to do it this time is kind of compare and contrast using Leaflet all by itself and then how it looks when you use Esri Leaflet too. So in this example, Leaflet has its own tile layer. This is a generic cached map service. If you want to load a map service that is tiled, you can say, tell it what the URL is, and you have to know the exact URL and you have to know that tile scheme of the zoom levels and the X and Y cache. and what the file format is, and you have to know how to attribute it, and then you get this Slippy map. So it's not a lot of code, it's pretty easy. And down here we got some static attribution. So this is pretty straightforward, a couple lines of code to get a tiled service. That's great. When we use Esri Leaflet, we've got a lot of really sweet base maps that our cartography team works hard on. There's World Topo Map and Street Map and the Gray Map, a lot of these maps. He said, let's make it even easier than that. Let's just tell us the name of the base map and load it. So we have to still load leaflets, CSS, and JavaScript. Then we've got a little Esri Leaflet dependency as well. Now we namespace, we follow the same pattern as Leaflet itself. All of our objects are nested within the Leaflet namespace. In the Esri namespace, base map layer. And you tell it which one it is, and you can add it right to the map. And here's a Slippy map here with World Street Map in South America. The cool thing here is, because we're following the sort of patterns of Leaflet, Esri base map layer inherits from Leaflet tile layer. So all of the base map constructor options and methods that you can use with tile layer, you can also use with base map layer. So looking at our API reference, it's a little sparse because we're not reproducing all the API doc that comes from Leaflet itself. We've got links so you can find your way back, but we don't repeat it. The other thing to notice is, as we kind of pan and zoom around here, Esri's got base maps. We're collecting data from a lot of individual providers. So in some areas, the people who've contributed data to our base maps different than another area. So as we pan and zoom, I don't know if you guys were paying attention, here at the bottom, that attribution is now dynamic and live. So one line of code gets you the base map, you don't have to know what the URL is, and you get this dynamic attribution. That's just some code that we wrote under the hood. You don't have to worry about how it works. And you don't have to know about the attribution to begin with. All right, so that's just one of the core classes. We're going to talk about some more Esri Leaflet classes, but I want to segue back to just Leaflet to give a frame of reference. So GeoJSON, if you guys haven't heard of it before, JSON is the curly braces, and what you stick inside the curly braces, the syntax defines one object type from another. So GeoJSON is one standard for denoting geometries and attributes for features that's widely used on the web. Esri has its own sort of flavor of JSON we've used for quite some time. In Leaflet, GeoJSON is a core commodity. That's kind of a generic. There is a Leaflet object for GeoJSON. You can pass a single geometry or a feature or a collection. So if you've got data on a server, or if you want to write all this out in your application code, you can take a JSON object literal, make a GeoJSON object, and then really quickly you can bind a pop-up to that layer and dig into those coordinates. So if I want, if I have a pop-up for this, I can really quickly bind a pop-up with one of the attribute columns, the value in that attribute column. So that's not too bad. It works okay. But when you have a lot of data, that can become a little more unmanageable, or there can be a lot of overhead in dealing with the data. So same thing, we're going to build on the fundamentals here. So if you've got, whether it's an ArcGIS Online hosted feature service, or you're using ArcGIS Server and publishing map services, the individual layers in the map, there's a URL that refers to that particular layer. So you can pass that to Leaflet and say, I want to make a new l.esri.feature layer. This is the URL of where my buses are. You can draw them all. Or you can say, I want to dig in and I only want to draw the features that satisfy a particular SQL condition. And then you can use the same pattern of binding the pop-up. You get a callback. So here, bind pop-up is a method that accepts a function argument. And in that function argument, I'm using a nifty arrow function. You can kick it old school if you want. Either way, you can dig into the layer. So in Esri's parlance, layer means the feature class and all of the individual features. In Leaflet parlance, the layer is like an individual layer in the map. It has feature and properties. So let's look at this in a little more detail, or just kind of snoop in the traffic. This is the same demo. So here, as I pan and zoom the map, if I look at the network traffic here, and then my little cursor. So here, we've got a bunch of queries to ArcGIS Online. And what we're doing with each one of these queries, if I click on one, I can see in the headers and the query string parameters, we're making a series of requests to fetch that data back. So we say, yeah, we want the geometry back, we want JSON, we want WGS84 as the coordinate system, and this is a bounding box, and we want F equals GeoJSON. So this is ArcGIS Online, give us back GeoJSON. The reason why there's a lot of queries here is it's more efficient for us to break up the current map extent into a repeatable grid so that we can take advantage of browser caching. So in your code, all you write is this, you know, the buses and add them to the map. You can bind the pop-up if you want. And then we handle the heavy lifting under the hood to figure out the cache structure, make the requests, handle the responses. If you use ArcGIS Online or a new version of ArcGIS Server, you get GeoJSON, that's awesome. If your organization is still using an old version of ArcGIS Server that doesn't know how to admit GeoJSON, Esri Leaflet handles that too. You just pass the URL and then we'll turn it into GeoJSON when it needs to be. Questions? How old is too old? I'm pretty sure GeoJSON support landed in ArcGIS Server at 10.3.1. And it's true unless anybody proves me otherwise before the hour's out. I'm pretty sure it landed in the service pack as opposed to the other. So it's been a couple of years, I think, but some people, you know, some IT staff moves more lightning than others. So that's probably enough to show about that. Let me get 15 minutes in. I think we're doing okay so far. So, and this is a pretty, and I think sometimes people forget, this is a pretty powerful thing that if you got like a handful of features, a flat GeoJSON file's fine, but if you've got a data set that has thousands or tens of thousands or hundreds of thousands of points, those can be stored on the database and you can just selectively fetch a subset and manage the response. This is a really nifty thing, and if you've got, say, polygon or line geometry, you can even simplify that output geometry to increase the performance. So on the server, we have really high precision geometry with a gazillion vertices, but Esri Leaflet helps us simplify it so that it just draws quicker because we're not editing or doing something else like that. All right, tiled map layer. A lot of you guys are using Esri's hosted basemaps. A lot of you are not. So it's very simple for you to point at your own cache map service. If you've already cached the tiles and your base map's done and you want to use a custom base map, it's still a one-liner. This is another class that inherits from L.tileLayer. So you can restrict the zoom level or manipulate that layer, do some things with it like that. The caveat here is Leaflet stays small by living in a Web Mercator world. And it's not that you can't use custom projection base maps in Leaflet, but if you do, you're already writing some custom code to translate that projection. So GIS folks go, what? Only Web Mercator? It's the standard, so that's what Leaflet sort of works out of the box. And there's pros and cons to this, right? Web Mercator has its drawbacks, but it's kind of a cool feature of Leaflet that, well, for web developers in particular, that people can almost conceive of latitude and longitude, but when you talk about Web Mercator actual northings and eastings, it's kind of like mental gymnastics. So this idea that Leaflet has a whole platform where I only have to worry about lat long, and then under the hood it will be Web Mercator and I don't have to worry about how, that's just kind of a simple practical thing for most developers. If you want to do custom projections, you could do that too. We have some code samples, but you're already talking about like 50 lines of code before you've even started. Another layer type. So say you have a map service that you haven't cached, either because you didn't feel like it or the data is changing so rapidly that the cache would be out of date. So in this situation, we don't want JSON back from the service. We want ArcGIS Server to draw us an image dynamically, think about it, and return us that image and overlay that on the map. In that case, we do the whole thing at once. And in this example, same thing, you point at the URL of your service, wherever it lives. You can just ask for the map that was in the MXD when they published the service, or you can do some nifty things like supply a custom layer definition expression to say, for layer 0, don't draw all the features, only draw the features if they have a population rank that's the highest. So this idea that the image export request can be customized is pretty nifty. And another thing is here, dynamic layer, we don't have any graphics or geometries that we can interact with instantaneously on the browser, but we can still bind pop-ups. So if I click on one of these cities, if I can click good enough, there's like an iframe going on, so there's some weird stuff. What happens is there's a little bit of delay there because the way the bind pop-up implementation works in Esri Leaflet, because it's just an image, when you click, we make an identify request and then handle the response. So same thing, you get back GeoJSON and deal with it. It's not quite as instantaneous, but sometimes it's the right move depending on how much data you're trying to display at the same time. All right, so image map layer. How many of you guys work at organizations where you're publishing not just dynamic map services, but image server layers? Yeah, okay. So I don't know, you guys are shy. So I don't really know a ton about, I took a remote sensing class in college and I realized that there's a lot more to learn. But from what I know about image service is this idea that it's primarily raster data, right? And you can have just aerial photography and red, green, and blue, normal, show me a picture of what it looks like from above. But we've also got really complex image service capability like Landsat or any of these other satellites that have 6 bands, 8 bands? I think it's 8 bands in Landsat. So you can see near infrared or some other electromagnetic frequency that's not visible. And what I never realized until writing up this demo or sort of put it all together was another capability of an image service that differentiates it from a normal dynamic map service is beyond just choosing bands. So it's cool to say, I want band 4 and 3 and 2 or some other combination of bands. This idea of a raster function or a rendering rule that applies some math and composites or in some other way treats the bands and does another interpretation that's going to have some validity to it because people other than me are doing it. This is an image service from Landsat. To give you a concrete example, if I choose one of these other raster functions that are supported, one image service can show me bands 541 with a dynamic range to highlight the agriculture. We can see something that highlights geology because it's shortwave infrared, bands 6, 3, and 1 with another stretch applied. So if you're a remote sensing person, having one data source be that malleable is really nice. And the way that it's implemented in Esri Leaflet, you can see the same thing, URL of the service. If you want to supply bands, you can supply those as an array. If you've got a time-enabled image layer and you want to dig back to a particular snapshot in time, you can do that with normal JavaScript objects. But what I'm showing here is this idea of JSON raster functions. So we follow the convention of the image service, define a rule, and supply the rendering rule either when we construct the object or manipulate that after the fact and then redraw it, make a new request. I thought that was pretty cool, mostly because I'm not that familiar with it. Those are some core classes, the feature layer, the dynamic map layer, the image layer. There's also some low-level tasks. Like I said before, we've also got this small ecosystem of plugins that do more with Esri Leaflet. So if you're doing address search and geocoding, there's a plugin for that. If you want to do something as customized as just drawing the renderer that's defined by the service, you might think that would come in Esri Leaflet out of the box, but we separate that out into a renders plugin. We do have stuff for GP services. We wrote one recently to draw vector-based maps that are Esri hosted and published from ArcGIS Pro. I've also got a new demo for some driving directions. I'll show you those as well. So we're into the territory of some plugins, and I want to talk about some stuff that we've been working on internally and also show off some stuff that the community's done. The ArcGIS Online web maps, this idea of specifying a web map by an ID was written by a developer in Japan. The stream layers was a GeoEvent processor sort of extension for Esri Leaflet to use WebSockets and draw real-time data in Leaflet. That was written by a developer. He's either he's Australian. He's not from New Zealand. I know people from both places, and they don't like it when you act like it's one place. I'll show off a couple of those samples here in a minute. So now we're into the what's new section. What's new with Leaflet? There's probably a few of you in here who've been tracking Leaflet development for a while. There was a long time span in which Leaflet struggled to move from a 0.7 release to a 1.0 release. We had betas and release candidates, and that progress moved really slowly. But Leaflet 1.0 hit maybe 6 months ago or so, and since then we've kind of picked back up in a normal or a nicer rapid development cycle. So the most recent release of Leaflet is 1.0.3, and that's good to see that patch release cycle is speeding up, and that's good for the Leaflet development community because it makes them realize that Leaflet's stable and that it's time to upgrade all the other plugins. So the most recent release with Leaflet 1.0.3 was dealing with native pointer events so that you have parity between touch and mouse events. But other than that, there's not a whole lot of new features. So digging a little bit more depth, some new stuff that we've come up with since the last time you'd been here. The web map plugin that I showed you about, the vector plugin, there's some links in here to the GitHub repos. The web map plugin is another really nice, simple plugin. If you know the ID of your ArcGIS Online web map, you pass that, create a new web map object, and pass the leaflet map to it, and then you can draw the layers. So this picks up on web maps. It knows about its what base map is being used, what the current extent is, what layers are included, what layers are currently being drawn. It allows you to do stuff with the pop-ups as well, so there's an implementation of pop-ups. And if I go back here to the doc, it's got very good web map support, but it's not exhaustive and complete web map support. So this developer in Japan, his name is Yusuke, wrote really great documentation. He wrote a really great plugin, but the thing that I'm the most proud of is he wrote a dedicated documentation page that outlines the entire web map spec and which things are implemented already in the plugin, which that takes effort. And I think it's a really nice thing as a developer to see something documented so well to decide whether you're going to be able to use it or not. So next one is the vector tiles. So vector tiles are really cool. They're drawn using WebGL, so we have vector data. For Esri, it's really awesome that we can take one authoritative base data, the service, cache the tiles, just the geometry and the attributes. And that cache is monumentally smaller than the tile caches we used to do for raster tiles for the whole world. We get one compact cache, and then we get to use it over and over again and just use JSON to style it and do the cartography. So it's great for us. We're able to publish a lot more base maps. And as you pan and zoom, you can see that there's this sort of crispness. We don't have tiles filling in. There's a little bit more seamless drawing experience. Somebody had to, of course, draw this in Leaflet. The caveat here is this WebGL implementation on top of the Leaflet drawing pane doesn't allow for all the awesome stuff like rotation and some of the more modern things. So you get the base maps, but it's a little bit more limited functionality. There's a lot of cool cartography, but it's not the same thing as using version 4.x of the JavaScript API, which has some more support. So how did I blast through all the way to that? Okay, back to 17 slides ago. In terms of new features and cool stuff, that's some new stuff. In terms of bug fixes and improvements, we followed suit of the JS API. We don't have a powered by Esri logo in the corner anymore. It's just inline in the attribution, so it's a little bit less pronounced. We did some work on multi-polygon GeoJSON, base64 images that some ArcGIS server instances support, and some user experience stuff with regard to our geocoding, like address search and autocomplete, to capture some edge cases that were presented by users. We also broke out some of Esri Leaflet's dependencies and internal code into external generic libraries because we thought they might be useful to other folks. So there's three major ones here. The first one's published to NPM. It's called ArcGIS to GeoJSON utils. So when we need to parse and translate Esri JSON into GeoJSON, we do that through some JavaScript code. And if you go way back in Esri Leaflet history, we used, I think, Terraformer as a dependency, and that worked. The code is very similar, but it was a little heavy because it wasn't just this module. Then we decided to put the code in Esri Leaflet, and that was okay too. Then we decided we'd refactor it again and take it back out in a way that's completely self-contained and doesn't have any other external dependencies. So this is like pure nerd reorganizing the closet stuff. But if you're interested in using a utility library that just parses back and forth between those formats, it's there, it's written in ES6, it's shipped as a UMD module, so you don't need to necessarily use something like Babel or any of those new crazy tools. You can just use regular JavaScript. That's cool. Another dependency that we broke out and separated as its own code base is Leaflet Virtual Grid. So this is what breaks up the map into a series of equal sized tiles so that we can take advantage of that browser cache when we fetch features. So this implementation is completely generic. It has a default pixel size of cells, and as you zoom in and out and pan around, it creates cells that correspond with where on the map has actually been interacted with, and provides some callback functions, so you have hooks on when a cell is created, when it's entered, and when it's left. Another library here is a binary search index. So this idea of JSON key value pairs. We keep track of our features that are on the client side using this binary search, but this is so generic that you don't even necessarily have to use it with Leaflet. So you can check that out if you're interested. And then in terms of what's really new, if you're interested in the source code of Esri Leaflet itself, we refactored and wrote ES6 modules and started using Rollup to compile that and ship it. Maybe 18 months ago, and that was a bit of a R&D project, and it worked out pretty good, and the Leaflet core contributing team kind of took note of that and decided, they waited a little while, but they've finally shipped and followed that same pattern. So this is something that's landed in Leaflet since 1.03, so the next release of Leaflet that you're going to see is going to be 1.1.0. If you're not deep in the source code, don't worry about it, but if you are, it's just kind of, it's a nice to have. It's just a sort of a new way of doing things that makes it a little easier to manage your code, and it's just a nice thing for JavaScript developers. All right, some new demos. So we needed to show some new stuff that you've never seen before. This is an example of labeling feature layer, and we got 50 states. We don't have room for 50 labels, so we need to have some sort of collision detection. And I found a library a little while back that works in Leaflet. It also works in open layers. It's a mapping library agnostic collision detection library. It's called LabelGun. It's written by a former UK Esri developer and a couple other folks. So this idea that we can not only use it to make sure labels don't collide, but we can also prioritize or rank arbitrarily which features should be more likely to be labeled. So in this example, I'm using the population of the state and saying states with a higher population, those labels are more important to me than the Rhode Islands and the Vermonts of the world. And that's unfair, and it's completely arbitrary and senseless, but that's just my lack of creativity in play. So this is a code sample. In addition to, this is using Esri Leaflet. In Leaflet, we've got LabelGun, and LabelGun depends on RBush, which is a quad tree index JavaScript implementation. Here's a function where we define that arbitrary rank. So if the population's greater than 20 million, that gives you the highest rank and the most likely to get labeled. And that weighted collision detection, the way it works in applying it to the feature layer, we need to create a bounding box for the whole label because the labels aren't all the same size. A big label's gonna collide more frequently than a small label. So we define that bounding box and then just ingest individual labels into the engine with the corresponding rank and let that algorithm work. So if we take a look here at the example, here's the live example. As I pan and zoom, it'll start to draw, add more labels, and refresh on the fly. So this is like an interactive thing. We just throw away the old engine and instantiate a new one every time. So another one people have asked for is driving directions in Leaflet. And my strong suit is not writing UIs in web applications. I like tend to hang out in the closet. So, but people wanted to see it, so I decided we should do it. And I got a little UI here. Let's switch again to the live sample. I'm going to kill some of these. So here's that same sample in full screen. I've already drawn. I just have the route happen automatically when you load the page. But here you can see after we create the route, you can hover over individual elements. You can also pick up and drag the route, add an intermediate stop, and have it recalculate or reverse directions. This is cool for a couple of reasons. The primary reason being that I didn't write the UI. I found that another Leaflet contributor had already written a generic routing and directions UI plugin for Leaflet. They call it the Leaflet routing engine, or Leaflet routing machine. And there were already a handful of existing providers. And OpenStreetMap is awesome. The OpenStreetMap router is good, but it is obviously not commercial grade, highly available, like the same quality of routing that you're gonna get out of Esri's hosted service. So writing another provider so that you could use Esri's service, that unlocks a couple of different things. One, we have walking directions, we have driving directions, we have trucking directions. You can go solve for either distance or time. There are other insane attributes under the hood that I haven't exposed, but if you're want to route ambulances down the wrong way down one-way streets, you can do that with our routing service. If you have an electric vehicle and you need to route near superchargers, you can do that with some custom attributes. So there's more opportunity for extension. But at the end of the day, we've got Leaflet. This does not rely on Esri Leaflet. This is just another random Leaflet plugin. But we've got the Leaflet routing machine. I didn't do the work to use our geocoding service. I'm still using OpenStreetMap for the geocoder. And then this Leaflet routing machine Esri is the plugin that I wrote. And that makes it so that all you have to do in your app is create this new routing control and specify that you want Esri's routing provider as opposed to one of the other ones. So this is nice. If you just want to use it, feel free. It works. If all you want to do is walking, driving, trucking, distance, time, that's all done. If you want to get in under the hood and think about how it works, basically, the way that we ask the Esri routing service to tell us whether we want walking or trucking is via some JSON, and there's a bit of text there. So I load that as a separate profile, load it into my code, and then just choose the profile based on the name. In this case, the default service URL is this Esri's World Routing Service. This one needs a token, so you need to authenticate. So I have an example here where you have the user put in their username and password for ArcGIS Online and use their own token. I have another example where we use a service proxy, so it just works and the credits are billed against the developer account instead. So the service URL is set by default. You can change it. We've got some defaults. By default, I use live traffic. So we let people decide if they don't care about live traffic. They don't want that to be incorporated into the solution. Then basically I just took one of the original providers and copy and pasted and start tearing it up and rewriting it so that I make the appropriate request to the routing service. So here we've got some parameters that are always the same. We always want the stops, we always want JSON, we want the complete directions. Then if people want live traffic, we'll append that parameter. If they chose a custom profile, we'll append that as well. If they have a token, we'll append that. Then we make that request based on just concatenating all the stops, longitude, latitude pairs. So that was all built in, that's great. Then once we parse the result, this is not just Esri flavored JSON, there's a cool compression technique. The geometries that come back from the World Routing Service are this compressed format. So up at the top, that BDQJF, that is geometry somehow. And I'm too feeble-minded to have ever figured out how that translates back into latitudes and longitudes. So luckily, I just looked online and found that we'd already open sourced some a JavaScript implementation of parsing that compressed geometry. I embedded this as a new private method in mine, and basically the only thing I did different is just take the Y, X values that came out and cast them to a leaflet lat long. So gnarly code that I don't understand and you don't have to understand. If you do, congratulations. I wish I was with you. So I got 10 more. I think we're doing pretty good. I still got 15. Okay, I got a few more. 42 slides in. Oh, let's show this other example though. So just to differentiate, so the sample I showed you, it just routed. I didn't authenticate, I just had it set up. This one is the same example where we use OAuth. So I have a little sign-in dialog. I get redirected to another page. You guys have seen this when your aunt invites you to join Farmville and start playing Farmville with her, right? So this is a technique for authentication where I have my app hosted wherever I, have my web server, but I don't ever handle the user's credentials. The user goes directly to the authoritative, ArcGIS.com, the authoritative place, and put in their username and password straight there. This is how you know it's Thursday afternoon. So if it's okay, I approve, and then ArcGIS.com provides a temporary token that gets passed back to the application, and then I can route. Right? So you guys have seen this pattern before. I think there's a lot of folks out there who have seen that, but digging into the guts and thinking about how that works, it's worth doing a little bit of a derail. So in implementation practice, let's talk about the second example first, this OAuth technique. And I've got all the code up so you can dig into it, but in general, the idea is you have to have either an organizational account or a free developer's account. Before you wrote any code, you just go in here and they just changed this the other day, so it makes it hard for my demos. But here you've got a dashboard of your applications and your layers and things that you're managing. I think it's this one, it might be another one. But creating an application in here, nobody could write down my secret that fast. Creating a secret in here is as simple as saying, hey ArcGIS.com, I'm gonna write some code later, but just give me some kind of a placeholder. And when I write the app, I'll plug in all this stuff later. And at a minimum, what you need to do the OAuth implementation is just this client ID. So there's a secret as well, but we don't need that part. If you just have the client ID, that tells ArcGIS.com that there's gonna be an app somewhere that's gonna ask users for their password. And then the only other piece that you need is, here in the Authentication tab, these redirect URIs. So this is the kind of gist of your covenant with ArcGIS.com as a developer. We're not just going to give tokens out to anybody anywhere. We need to verify that this app is bona fide and that it's not a malicious entity that's asking our users for passwords. So when we pass back a token, we first check, and in your app you supply the client ID, and we know what your redirect URI is because you're asking for the token to go back there. And if those two things match, then they get a token. And if not, we say, no, we're just going to make this not work. So in your code, you supply that client ID. So I'll show you the example here. I don't think I was too lazy to get it out of my own account, but this is LRM-Esri. There's a link in the slides. Here in the examples, in the OAuth section, this app.js, here's where my callback page is, and we've got some examples that you can use. The callback window, here's how we invoke redirecting the user straight to ArcGIS.com, and then pass in this client ID that comes here from a variable. So your client ID has to be different than mine because your redirect URI is different than mine. And after that, we just route. So that's the OAuth implementation. The other implementation here is, bear with me, without OAuth, if I just want the app to let people route without putting in their own credentials, there's a few different ways to do this, but my preferred technique is this notion of providing a service proxy. This is a custom URL of mine. It really just calls the same routing service as everybody else uses, but it's a URL that only I know about. And I can provide some limitations here, some enforcement on rate limiting this and whitelisting where the requests come from so I can get a little bit of security. The way that you do that is very similar to the last. We go to the dash, even in the same thing for an application. If I scroll down here to the section in the Authentication tab, pass their credentials, here's the service proxies. You can generate service proxies. They're associated with one of your apps in the developers.arcgis.com website. So org account, free developer account, either way, I say, yeah, I'm interested in a new service proxy. I want it to be doing regular routing. That was the one I chose. So you set up the parameters here, and then you get this URL. You paste that into your app, you skip the OAuth stuff, and it just works. And then when somebody wants to route more than 1,200 routes in a month, we send you the bill. All right, getting towards, there's not too much left for here. So another sort of benefit of Leaflet, or thing that some folks like about Leaflet, is it's written in vanilla JavaScript, so it plays very nice with all the build tooling that's out there. So some folks don't use any build tooling, that's fine. Some folks use Browserify, Webpack has become more popular. We use Rollup for building the API. Whether you choose one or the other, it's a positive sort of feather in the cap of Leaflet that it is agnostic enough. It doesn't really care. It'll let you use whatever you want. So if you already know what you want, great. If you don't and you're kind of interested in learning more, these are all links to samples that we wrote, implementations that use Browserify. And the general principle of why people might use these build tools is to wrap up all of their own code and all of their dependencies. So you're probably using as Leaflet and Esri Leaflet and maybe some other plugins, bundling them all together because they're a lot of individual files that aren't that big, and wrapping it up so that there's only one web request. And that's something that increases the performance everywhere a little bit, but it's really beneficial on mobile devices that have sometimes slower bandwidth and a lot of times a little bit more trouble with latency in between individual requests. So there's some samples there that you can check out. Any of that stuff is fair game for you to rip off. That's almost everything I've got. You know, whether you're just trying to build better apps yourself, if you want to contribute back to Esri Leaflet, I have a great time working on it. If you haven't sort of seen it already, here's something we've got in the hopper right now. We're just about to release 2.0.8. You can see the features that are going to be in there and the bug fixes. Don't be shy. If you've got a question, you know, and you want some clarification on something, or you want to talk about an issue, we are proud to maintain a really friendly environment. We're onboarding folks that haven't used GitHub much before, so don't be shy about asking a question and worrying about somebody chirping at you. We would love to hear from you. We'd love to hear what's working and what's not working, and what you'd like to see that's not here yet. You know, Leaflet's, I'd say in general, it's fair to say that it's maturing, and you're not seeing a lot of new features in Leaflet core. The plugin ecosystem is still jumping, but we're kind of maturing out as well. So we're looking for feedback from you guys as to what you want to see next. In terms of, you know, I love GitHub. It's a great place to go. You can. That's not the only place you can go though as well. You can log tech support tickets. There's the spatial communities, a public Slack channel if you're looking for some interaction with folks from all over the world. Stack Exchange and GeoNet are good places for Q&A. There's a lot of good content already there, but we'd love to see your activity there as well. That's it. I've got my necessary indiction. I'd love to see session surveys. I have thick skin, so if you've got any criticisms, recommendations for things you want to see more of or things you want to see less of, don't hold back. You guys want to hear a funny story? We've got time for it, right? Yeah, we got time. So when I was looking through the survey feedback from last time, it's all dumped into a spreadsheet. And the feedback, I'm not saying too much, the feedback was pretty good. And I was like, all right, good. And most of the people said, yeah, it's great. And a few people said, man, I'm not using Leaflet. Thank you for that talk that steered me away from it. And that is okay too. Like I consider that's a goal of my talk, is I don't want to steer people towards the thing that they don't want to be using. But there was this one category of like, would you recommend this talk to your worker? And everything else is like 5s, 4s, mostly 5s and 4s, maybe a 3. This one's like all 1s. And I was like, who do you guys think you are? Like, you think you're the only open source kid in your organization? Like, it was a good talk, but you wouldn't share the info with your coworker? Like, your coworker might want to learn about it too. I had this whole thing. And then I was like, no, that's a yes or no question. It's either 1 or 0. I'm glad you guys thought that was as funny as I thought. All right, we got 10 minutes for questions. If you're shy and you want to reach out to me, it's john@esri.com. You can come on up if you want to ask a question in front of the crowd. Have at it. But otherwise, thanks for joining me.